Hey everybody, we're gonna get started in a couple minutes here. Yesterday I had meant to record some of the classes for the students, but it became like very grainy because of my internet yesterday. So I am gonna be recording this one. So I ask you to keep your cameras off until I turn off the recording. But if you wish to talk to me or raise your hand, that's still fine. So I'll let you guys know that's gonna be happening. We will be starting our presentation here in a moment, probably about 3 more minutes, and we're going to talk about the moon and the earth and the sun. Um, let's see here. There's some of you guys here. So most of you guys saw, I sent an email out for those of you who didn't finish your work on yesterday, I believe. This Monday is going to be your midterm. That's why I sent those emails out. So if you guys haven't finished something yet, please try to go on my MCPS Classroom and get that done so I can get your midterm in. And I'm going to turn this phone off so it doesn't bother us during all this. All this noise happening. Okay. And yeah, so midterm is on Monday. And since you guys are here, you guys are going to be fine. I'm just warning you if you have anything left over for other classes as well, or for me. Make sure you try to get those in by Monday. All right. I see Miss Khan is here. That's great. You have your mic off, Miss Khan.
Hi, Mr. Brando. How are you?
I'm all right. How you doing, Miss Khan?
Good, good. Hi, everybody.
Hi.
All right. So we'll start a minute early. So when people show up, we'll catch them up on what we're talking about. So this is let me put this in presentation mode. So it's a little bit bigger. There we go. So we're talking about the moon this week and the phases of the moon. And one of the main things I want to point out with this picture here is the Earth revolves around the sun while it rotates, and then the moon revolves around the Earth. Okay, it goes around the Earth. So that's the model we know of. And if we look here, the moon, just like Earth, has layers. Remember the whole Shrek thing? It has layers, right? But we believe the moon came off a couple million years ago from the Earth. And so it has mostly this very, very thick mantle. It's almost solid all the way through, except for the very, very center. And in the center, we have some liquid there. It's not very much, but there is some liquid, and this causes a slight magnetic pull. So there's some magnetism, but not very much compared to our planet Earth. And this part here is very, very thick. And the reason why we think this is back in the 60s and 70s when we launched our space shuttles up there, we put a bunch of these little seismometers all over the moon. And what we call moonquakes are basically kind of like earthquakes, but on the moon. And we measured them. And they're very, very, very slight. They're not very strong compared to Earth's. And they're not as frequent. So that's why we think that the moon's mantle is very thick and solid. The other thing we noticed is, if you look at this picture of the moon here, see how all of this area, I'm kind of highlighting with my mouse here, is all like smooth? Well, we think, well, we're pretty sure of, what happened was not too long ago, in geologic time, about 10,000, maybe 100,000 years ago, a comet smacked into the moon and actually got into this area of the core, and this lava came up and made all this new rock, which is why we know that the very center of the moon probably still has this liquid part. There is still some lava on the moon, just not as much as on the Earth. So most of the moon is solid, doesn't have as much earthquakes, and because of that, we consider the moon to be what we call geologically dead. That means there aren't any volcanoes that actively erupt on the moon. And we learned back in our geology chapter that those volcanoes are part of the reason why we have an atmosphere. So that can explain why the moon has a very thin atmosphere, and it doesn't make it very suitable for us to live on. Because again, there's not much below the core. The surface is a very solid surface. So there's nothing really to like spew out any kind of gases. So if we were wanted to live on the moon, the positive side is there's no earthquakes, there's no moonquakes, so we don't have to worry about that. But we'd have to figure out a way of bringing our own atmosphere and bringing our own liquid there. The next thing I want to bring up, the fact is the word the moon. Well, moon just means any spatial body that orbits something other than a sun. So like you might have heard the word satellite before. That's what that means. Moon and satellite are kind of interchangeable. So anything that goes around another planet is its moon. So like Jupiter has like 16 moons. Mars has 2 moons. So when we talk about the moon, you have to say Earth's moon or the moon for us to know we're talking about Earth's moon. And if you didn't know this, Earth's moon actually does have a name. And its name is Luna, named after the Roman goddess Luna. So if you don't have to say the moon or Earth's moon, you could just say Luna, and that means the moon. And this name has been used a lot in a lot of like fantasy stuff and whatnot. So I picked my favorite name for Luna, Luna Lovegood over here from House Ravenclaw, even though I'm a Hufflepuff. It's okay. There she is right there. So Luna, Luna Lovegood, moon. Okay. Also, that's where we believe, well, it was like a thought, that the moon, during its cycles, during a full moon, you can act a little silly or crazy. So that's where the term loony comes from, or lunatic. So Looney Tunes, lunatic, all comes from the moon or Luna. Okay. And if you remember, Luna Lovegood's personality kind of fits that. She's a little out there, but she's really cool. I like her. So let's move on. So how does the moon work? So big fancy science word here, it's a dichotomy. It needs 2 things. That's what dichotomy means. It needs itself and it needs the sun. Without the sun, we wouldn't be able to see the moon. So the moon is actually made of the same rock that's in concrete. Okay, so if you're driving down south in the southern states, you like to use concrete instead of asphalt for highways, or if you're driving down to DC, if you're going to go over a bridge, that concrete, that light cement, that's the same kind of thing that the moon is made out of. And if you go on a sunny day during summer, you look at it, it's going to hurt your eyes because a lot of it's reflecting back. That's what happens on the moon. When the sun hits us almost concrete-like rock the moon's made out of, it reflects that light back to Earth, and that gets to our eyes, and we're able to see the moon. If where the sun's hitting it, the reflection doesn't get to Earth or our eyes, we can't see the moon. It doesn't mean it's not there. It's just it's not illuminated. The moon itself does not produce its own light. So when we have a new moon, we look up in the sky, we don't see anything. The moon is still there. If we take lasers and we bounce it off of the moon, which we've done, it's still there. We know it's there. We just can't see it with our eyes. Okay. And down here, that's why I have this picture of the Pokemon, the sun and moon, because they need to be together to be able to see each other. Okay, or get the whole picture. So that's how we see the moon. And because of that, as the moon orbits the Earth, or revolves around the Earth, we talked about earlier in this unit. I'm going to throw this phone on the ground because it's being annoying. All right. So as the moon revolves around the Earth, it has this synchronous orbit, which means one face of the moon is always facing the Earth, no matter where it is. So that's why when the sun that's coming from over here from the right hits the moon, in this position here, it's hitting what we call the dark side of the moon. It's not actually dark in this situation, it's actually all lit up. But as we said, it's all about the reflection reaching our eyes, so when the light hits this part of the moon, it just bounces back into space, so we don't see it. And we call this a new moon, okay? Because it's new, because you can't see it, and it's dark. Then it goes through this cycle. This takes about 28 days to 29 days. It's called the lunar calendar. And about a week later, the sunlight will move across the moon's face from east to west or right to left. And the first thing we'll see is like a crescent. So when we see this little sliver, we call that a crescent. And after about a week, we'll have a first quarter, or we'll have like a half moon. Okay, where half of the light that's hitting the moon is reflected back to Earth so we can see it. The other half is getting reflected back into space, so we only see about half the moon. Then another week passes, and in between this one, we have this thing called a gibbous. It's a fun name, gibbous. And that just means we have a crescent of darkness, okay? And there's 2 different types of gibbuses. If you look here and here, there's 2 gibbuses. And that's just talking about a crescent of darkness on the moon. And on which side it is will tell you if it's waxing or waning, getting bigger or small. So here we go. This in the second week, we have a full moon. That's when the whole moon is illuminated. All the light hitting the moon gets reflected back to Earth. Down here, after about another week, it goes through another gibbous. A crescent of shade shows up, but this time it's moving from right to left, and the light's going away. We get to our third quarter, where only half is lit up, and then another crescent happens, and finally in the fourth week, we get back to our new moon. So about 29 days, 28 days, and that's what makes up a lunar month or a lunar calendar. You might be asking yourself, why is this important? Most biological things on Earth run off this calendar. If you didn't know that, there's many insects that will only spawn or hatch during a full moon, and then they'll wait another whole month to come back out again. They'll hatch, they'll feed, they might even breed, and then they'll probably die and then come back at the new moon. Some plants wait for the full moon to blossom so that way insects can find them. Some species actually will wait to bloom till new moon, so things can't find them. Tides are linked to the moon. Many behaviors we see in animals are all linked to this monthly cycle. Okay, so if you want to do anything biology related, or even be a doctor, or be a psychiatrist, or even with city planning and engineering, a lot of things are linked to this moon cycle. Okay. And these are the two terms that we use. So when the moon is going towards a full moon, we call it waxing. It's gaining, okay? It's growing. And when it's coming back to a new moon, it's waning. The shadow's moving this way. The way I remember is, which way is the shadow pointing? If the shadow is pointing, so it's kind of bent this way to the right, that means we're waxing. And if the shadow is kind of pointing to the left, that means we're waning, because it moves from right to left. And just to help you guys out, the term waxing doesn't come from waxing your shoulder or waxing your body. It comes from waxing on a candle. Back in the day, we used to wax candles like this. And you can still do this down at Mount Vernon. You can go down there and they can pay $4. You can make a candle, and you'll dip it in and out of the wax. And as you dip it every single time, it gets bigger and bigger. Same with the moon. Every night you look at the moon during its waxing cycle, it's getting bigger and bigger and bigger until it gets to a full moon. Okay, and then it begins to wane. You might have heard my patience is waning with you. It's just getting shorter or less. So once you're at a full moon, it starts slowly going away. That's what waning is. And here's a little GIF of that happening. And remember, it goes from right to left. And while this term of gibbous is fun, and so is crescent, these aren't the most important ones. The main important ones you need to remember is first quarter, full moon, new moon, and the last quarter. These quarter moons, and then the full and new. Gibbous is cool to say though, so I still learn it. Okay. So as I said before, this is just a picture basically showing you how this reflection works. So right here, since the sun is reflecting all light this way, it's going to be a new moon. Let's get about here, it's a quarter, waxing gibbous, and then all the light here reflected back to Earth at this point is a full moon, half moon, waning, new moon. See how that works? The cool thing is, when we're at this full moon here, a lot of different things can happen here. Because if you look, the Earth is getting hit by the sun too, so there's a shadow that should be cast, right? So what happens when the moon goes through that shadow, either fully or partially? What can happen? Well, some of the things that can happen, and this is that month I was talking about, we'll talk about this in a second. You can either get an eclipse or something called a blood moon, and we'll get to that in a moment because I didn't realize these were out of order. But we'll talk about the moon phase real fast. So this is the lunar calendar. I've said this a couple of times, but the lunar calendar is something that many cultures use as well. The Chinese use it, the Lunar New Year, which is why it's a little bit further into our months, because it uses 29-day month instead of a 30-day month. And again, this is a lot better for tides and helping with biological things, because a lot of things on Earth are tied to this and not technically the 30-month day we use. This is better for our revolution. This is better for our moon and rotation keeping track of. So it depends on which one you want to use. Okay, so this is what I was trying to get to. was this whole shade thing. So this is our 29.5-day lunar cycle thing. And once we get to this page here we go. This is where the moon, the Earth's shadow can cause an issue. So if you didn't know this, the moon and Earth don't rotate like on a straight flat plane, okay? The moon's on a little bit of a tilt, so it kind of goes like a little bit like this. So it doesn't always hit the Earth's shadow. That's why we don't have a lunar eclipse every single month, okay? But once in a while in our revolution around the sun, the moon can go through the Earth's shadow. And we call this the umbra. If you play Pokemon, Umbreon means dark, umbra, get it? So when the moon's light gets reflected through this, if it's completely blocked out, if all of it falls into the shadow, we get an eclipse. But if that reflection only goes through partial of the shadow, or it just kind of gets reflected through it, it bends that white light. You might have learned in prior years that white light contains all the colors of the rainbow, Roy G. Biv. Well, it bends the Roy, the R, more than it bends the rest. So we start seeing a blood moon, or we call it a red moon. You might have heard of a strawberry moon or a harvest moon. And we should be getting one of those in June. So if next month you get a chance, you should look up in the sky when it's a full moon, because you'll be able to see what we call a harvest or blood moon. It'll be a reddish color or tint to it. I think I have a picture of that. Here. So here's a picture of the blood moon right there. See how like red that is? It's really, really cool because that's the light reflecting through the umbra. Okay. And now let's see if we can go backwards a little bit. All right. All right. The last thing I want to talk about is this, is perigee and apogee. This just means if it's close or far away. Because remember we talked about with Kepler's laws, orbits aren't perfect circles. They're a little bit elongated. They're usually oval shaped. And when it's closest to us, we call that perigee. And when it's farthest away, we call that apogee. Last month, we were in perigee. So we had a supermoon. That just means the light coming from the moon gets bent by our atmosphere to make it seem bigger than it is. It gets magnified. So it's way bigger than normal. It was really, really pretty, and it's really, really interesting to look at. Okay, this is what astronomers always look forward to in their backyard with telescopes, because they can see almost all the craters in the moon. That's how we named everything there. And we have this other part in apogee, and sadly, I think that's going to happen around October this year. You're going to see why I'm saying sadly in a moment. Which means it's going to be a lot smaller. The light gets basically bent in our atmosphere to make the moon way smaller than it normally looks to us, so it looks farther away. And this constantly happens throughout the year, so depending on when you look at the moon, it can look very, very small, it can look very, very big, and that's only because it's a little bit closer to us, and it's not that bit much closer, it's just that the light is bent and refracted differently in our atmosphere, making it a magnifying effect on it, so it makes it look way bigger or way smaller. Okay, so I'll get back to that in a second. So if we look here, this is that umbra thing I was showing you before. If we have an apogee or umbra, we can have a super blood moon, or we can have a tiny blood moon. So this doesn't really affect that too much. So let's, so as you can see right here is a super blood moon right there. And if you look over here, this is what it looks like when it's in perigee. It's small, but it's still that reddish color. So I'm going to go to this slide real fast. I know it's blurry, and I tried making it better, but I couldn't. But this is the one time I'm going to ask you guys to interact with me. So if you go into your participants list, you should have the yes or no buttons down there. And if you think this model here, where the sun's in the middle, and the Earth revolves around the sun, and the moon also revolves around the sun, go ahead and give me a yes. But if you think that's wrong, go ahead and give me a no. Oh my. There we go.
Better.
Thank you guys. You're right. This is not correct. This is a heliocentric model, but if this was true, we wouldn't see the moon every single day, okay? Because the moon might hide behind the sun or not be able to reflect the light properly. So let's go ahead and clear that out. Who thinks it's B down here? So the Earth's in the center, and the sun revolves around the Earth, and the moon revolves around the Earth. Seeing a lot of no's. That's correct. This is the geocentric model. Remember, geo is Earth. And we've learned that this is incorrect, right? So the Earth is not the center of our solar system. So how about this one over here where the sun is the center of our solar system? Earth revolves around the sun and the moon revolves around the Earth. You guys got it. Good job, guys. Awesome. And we're not going to talk about D, but D is just basically a different version of geocentrism, which is wrong. Okay. We're almost done. I just want to talk about one last thing, and I'll take some questions, and I'll stop the recording. So if we look here, there's a thing called a blue moon. When we say a blue moon, we don't mean the moon actually turns blue. Okay. What we mean is we have two full moons in the same 30-day month. Okay. So remember, we don't follow the lunar calendar here. We use the Georgian calendar, which has 30 days to 31 days. So it's possible to have two full moons in the same month. It's very rare. It only happens 2.7 years. But thankfully, it's happening this year. So if someone says, well, in the next blue moon or tries to blow you off that way, you can tell them, well, it's in October and you can be smart about it. So if you look in October, we're going to have ourselves a blue moon, and I suggest you take a look at it. 2018 was really, really interesting. So was 2001, because this is really rare where we had two blue moons in the same year. That doesn't really happen that often. Okay. So all blue moon mean is you have two full moons in the same month of the same year. That's not that special, but it's just something you should know about, okay? Because it's been used in like pop culture and things. And just so you guys know, this slideshow is up on Google Classroom. And there's a couple more things you can look at if you'd like. If you're interested about the moons of Mars, here they are. There's Phobos and Deimos, and they go around Mars. And you can learn how their moons are a little bit different to ours, but they follow the same principles. They still orbit a planet, and they still have, some of them have synchronous orbits, some of them don't. So some of them will have phases, and some of them won't. And this is from one of our rovers up there taking pictures of them. It's kind of interesting. And here's also some other moons in the solar system. If you look, I believe technically they say Jupiter has the most amount of moons, but if you consider Saturn's ring a moon system, there's more there, so debates. And that's about all I have to talk to you guys about with moons. So I'm going to stop the recording here. And if anyone has any questions,